Good day everyone. In this video, I will take you from your home to the outer space. Come on! Before that, let us read the competencies to be learned. Differentiate between rotation and revolution and describe the effects of the Earth's motion. Infer the pattern in the changes in the appearance of the moon. Identify star patterns that can be seen at a particular times of the year. Now, let's begin with our first competency. Differentiate between rotation and revolution and describe the effects of the Earth's motions. I am Romel L. Landicho, your presenter. Let's talk about Earth's rotation. Can you see how the Earth is spinning around its axis? This movement is called rotation. The Earth spins in the imaginary line which passes through the poles. If you look closely, you notice that the axis is a little inclined, almost 24 degrees. It takes planet Earth 24 hours to complete one rotation on its axis, which is the equivalent of one day. Rotation explains day and night. As you can see, it's daytime in the part of the Earth that faces the sun and nighttime on the dark side. Now, let's talk about Earth's revolution. The movement of the Earth around the sun is called revolution. The Earth takes one whole year to go around the sun. Before, people used to think that the orbit of the Earth around the sun was cyclical, but they weren't right. As you can see, here the orbit is elliptical. Thanks to revolution in the inclination of the rotation axis of the Earth, we have 4 seasons: spring, summer, autumn, and winter. The more the hemisphere is inclined towards the sun, the more directly the sunlight reaches the Earth's surface. It's warmer and that's why it's summertime. By contrast, the other hemisphere is less inclined, so sunlight is less direct. That's why it's colder in its winter time. Here, we can see that it's summer in the northern hemisphere and winter time in the southern hemisphere. The opposite will occur in 6 months. Sunlight will reach the southern hemisphere in a more direct way. It will be summer. Well, in the northern hemisphere, it will be winter. Owing to the fact that the revolution of the Earth around the Sun doesn't take exactly 365 days, but 365 days and 6 hours. There are leap years which have one more day, 366 days. That's why every 4 years, February has one more day, day 29. Now, here are the misconceptions. Baxter, 1989, identified 6 ideas about day and night and showed that students tend to move through these ideas as they get older. Now, let's talk about our second competency. Infer the pattern in the changes in the appearance of the moon. Moon around the Earth, its appearance changes in cycles to 8 different phases. The 8 phases are new moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, third quarter, waning crescent, and you're back at new moon. So, let's get to work these phases. First, the moon revolves around the Earth in a counterclockwise direction. An easy way to remember counterclockwise is to think about running the bases during the baseball game. You run in a counterclockwise direction. So, let's begin at new moon, which will be the home plate. It occurs when the moon is between the Earth and the sun. First base will be the first quarter. Second base will be the full moon, which occurs when the moon beyond the Earth and reflects the sunlight back. The third base is the third quarter, and then you're back at new moon. When you move from the new moon to the full moon, the light is growing, which is called waxing. An easy way to remember this is with the saying, light on right getting bright, which is waxing. Light on left is waning. When you go from new moon to full moon, the light is on the right, so you're waxing, and the light grows. When you go from full moon to new moon, the light is on the left. You are waning, and you are subtracting light. Now you have two more moons to think about, crescent and gibbous. A crescent moon has a small amount of light, and a gibbous moon has a great deal of light. An easy way to remember where these are located is that the crescent moon always appears before and after a new moon, and a gibbous moon always appears before and after the full moon. Now let's put this together. You have new moon, light is on the right, so you have a waxing crescent, and then first quarter, then a waxing gibbous. Now at your full moon, now you go to the waning gibbous, and the light now is on the left of the shadow, third quarter, waning crescent, and then you back at new moon. Did you know that it takes 27 days, 7 hours, and 43 minutes for our moon to complete one full orbit around the Earth? This is called the sidereal month. It is measured by our moon's position relative to distant fixed stars. However, it takes our moon about 29.5 days to complete one cycle of phases from new moon to new moon. Now, here are the misconceptions. Now let's talk about our final competency. Identify star patterns that can be seen at particular times of the year. Constellation. What is constellation? Constellation came from the word con, meaning together, and stella, meaning stars. A constellation is an area on a celestial sphere in which a group of visible stars form a perceived outline or pattern, typically representing an animal, mythological person or creature, or an inanimate object. The IAU recognizes 88 constellations covering the entire northern and southern sky. Here are the names of some common constellations. Ursa Major, also known as the Great Bear, is a constellation in the northern sky. Its Latin name means greater or larger she-bear. It was one of the original 48 constellations listed by Ptolemy in the 2nd century AD. Today, it is the third largest of the 88 modern constellations. Ursa Minor, also known as the Little Bear, is a constellation in the northern sky. The tail of the Little Bear may also be seen in the handle of a ladle. It was one of the 48 constellations listed by the 2nd century astronomer Ptolemy, and remains one of the 88 modern constellations. Ursa Minor has traditionally been important for navigation, particularly the mariners, because of Polaris being the North Pole star. Virgo is one of the constellations of the zodiac. Its name is Latin for virgin or maiden, lying between Leo to the west and Libra to the east. It is the second largest constellation in the sky after Hydra, and the largest constellation in the zodiac. Virgo is a prominent in the spring sky in the northern hemisphere, visible all night in March and April. As the largest zodiac constellation, the Sun takes 44 days to pass through it, longer than any other. Orion is a prominent constellation located on the celestial equator and visible throughout the world. It is one of the most conspicuous and recognizable constellations in the night sky. It is named after Orion, a hunter in Greek mythology. Orion is most visible in the evening sky from January to March, winter in the northern hemisphere, and summer in the southern hemisphere. Taurus, Latin for the bull. It is one of the constellations of the zodiac and is located in the northern celestial hemisphere. Taurus is a large and prominent constellation in the northern hemisphere winter sky. It is one of the oldest constellations, dating back to the early Bronze Age at least, when it marked the location of the sun during the spring equinox. Aquarius is a constellation of the zodiac between Capricornus and Pisces. Its name is Latin for water carrier or cup carrier. Aquarius is one of the oldest of the recognized constellations along the zodiac. It was one of the 48 constellations listed by the 2nd century astronomer Ptolemy, and it remains one of the 88 modern constellations. Aries is one of the constellations of the zodiac. It is located in the northern celestial hemisphere between Pisces to the west and Taurus to the east. The name Aries is Latin for ram. It is one of the 48 constellations described by the 2nd century astronomer Ptolemy and remains one of the 88 modern constellations. Pegasus. It is a constellation in the northern sky, named after the winged horse Pegasus in Greek mythology. It was one of the 48 constellations listed by the 2nd century astronomer Ptolemy, and is one of the 88 constellations recognized today. Draco is a constellation in the far northern sky. Its name is Latin for dragon. It was one of the 48 constellations listed by the 2nd century astronomer Ptolemy, and remains one of the 88 modern constellations today. The north pole of the ecliptic is in Draco. Can be seen all year from the northern latitudes. Cassiopeia is a constellation in the northern sky named after the vain queen Cassiopeia, mother of Andromeda in Greek mythology. Cassiopeia was one of the 48 constellations listed by the 2nd century Greek astronomer Ptolemy. It remains one of the 88 modern constellations today. It is easily recognizable due to its distinctive W shape formed by the 5 bright stars. Canis Major is a constellation in the southern celestial hemisphere. In the 2nd century, it was included in the Ptolemy's 48 constellations and is counted among the 88 modern constellations. Its name is Latin for greater dog, as following the constellation of Orion, the hunter through the sky. Canis Major contains Sirius, the brightest star in the night sky, known as the dog star. What are the uses of constellations? It gives direction, help track of the calendar, useful for navigation. Now, here are the common misconceptions about the stars. I hope you've learned a lot about the three competences we've discussed. See you next time!